past then. So exponential functions, we are here. Remember, we said whoever is here is not against their will. They're here because they want to be here. So modeling with exponential functions. Exponential growth, it means there are two of them. So there's one exponential growth, which is doubling, and there's one exponential growth, which is a relative growth rate, with a relative growth rate. And then we have radioactive decay, and then we have Newton's law of cooling. Now they say many processes in nature, such as population growth, radiative decay, heat diffusion, and numerous others can be modeled using exponential function. Now in this section, we study the exponential models. So let's look at an exponential growth. So they say, suppose that we start with a bacterium, meaning that it's one bacterium, which then divides every hour. After 1 hour, we have two bacteria. Ooh. After 2 hours, we have 4 bacteria. After 3 hours, we then have 8. So this, what is happening to the number, guys?
It's increasing.
How is it increasing? Am I recording? Yes.
It's doubling. It's doubling.
It's doubling. Therefore, it means that we are looking at the exponential growth, that is doubling time. So we say that we can model the bacteria population after T as this function here. Does it make sense? Guys? Does it make sense how they got T to the power of that?
Yes, ma'am.
Yes, ma'am.
Good. So they say that now, let's say we start with 10 of these bacteria. Then now the model changes. It's no longer T to the power of T. Will be, initially we started with 10 times 2 to the power of T in that particular hour. Now, let's say we are looking at a slower growing strain of bacteria doubling, but every 3 hours. Initially, the bacteria were doubling every hour, isn't it?
Yes.
So now the bacteria are doubling every after 3 hours, meaning that they are slowly doubling. Please mute. Now, in this case, the population is now modeled as this. It's no longer this one of here. So they're saying in general, then to model a population that is doubling time, we'll use this formula here. They say if the initial size of the population is N0, so this is when you start with the bacteria or babies or population or cows or donkeys or whatever. And the doubling time, in this case, they say 3 hours. That's why we divide it by 3. And the doubling time is A. Then the size of the population after time t is equals to nt equals to n0, which is 2 to the power of t over a, where a and t are measured in the same time unit, whether it's in minutes, hours, days, and years, or so on. Are we all together, yes or no?
Yes.
Yes.
So now they say, example 1, under ideal conditions, a certain bacterium population doubles every 3 hours. Let me take a screenshot so we answer this question. I need a screenshot. Here we are. So they say under ideal conditions, a certain bacteria population doubles every 3 hours. Initially, there are 1,000 bacteria in the colony. In a colony. Find a model for the bacteria population after T hours. How are we going to find that? Guys, how are we finding that?
We substitute in that formula.
Thank you. So we substitute back into this formula here because they're saying it doubling. So we then say, okay, where is it? Sorry. We come here and we say, okay, fine. Our formula says our n of t is equals to n0, 2 to the power of t over a. Now we know that our doubling time is what? Our doubling time is a. In this case, the doubling, it doubles every 3 hours. So meaning our a is equals to 3 when t, that's they want us to find a population after t hours, so we don't substitute there. Now the initial bacteria, which is n0, is equals to 8,000. So then this is n of t is equals to 1,000, 2 to the power of t over 3. Are we all together?
Yes, ma'am.
Now they say how many bacteria are in a colony after 15 hours. So what do we do?
Substitute the 15 by t.
Thank you. So we say 15 is equals to 1,000. Those who did not see the assignment, just know that this is part of your assignment. So 1,000, then 15 divided by 3, that's 5, then 2 to the power of 5. What is 2 to the power of 5?
Oh. 1.
Isn't it 32?
Okay. 2 times 2.
2 times 2 is 4. 4
Times 2.
times 2 is 8.
Times 2.
36.
Huh?
It's 32, ma'am.
32. So
Well done. So do you see that you don't need calculators for some things?
yeah.
Guys, use your brains. And then after how many hours will the bacteria reach 1,000? What am I looking at there? What am I looking at to find?
You're supposed to find the time.
No,
Because it's after
aren't you
how
supposed to
many?
find A?
We're finding NT.
We're finding T. Thank you. How many hours will the bacteria count reach? A is given. So meaning we are finding NT. No, sorry, we are finding T because N is given, right? N is the number of bacteria, NT is the number of bacteria that you get after T. So then we means we'll go say N of T is equals to N0 ET. Why am I? Yo, this E is in my mind, guys. T over A. So then we put a 10,000 here. We're not using a calculator, so let's solve this. 1,000, 2, T over 3. Come on. No calculators. Even in your assignment, we're not using calculators. So what do I do here?
Divide by
Divide
1,000
by
on
1,000.
both sides.
Thank you. Divide by 1,000. So if I divide by this 0 cancels that 0, this 0 cancels that 0, 0 cancels that, then 10 divided by 1, this is 10. 2 to the power of t over 3. And because I want t, I'll write t. I had a huge no. What's going on?
No, it's a log, man. It's a log.
Oh, sorry, guys. It's 100,000. Did you see that? It's not 10,000.
It's 100,
Yes.
therefore 100.
Thank you. So then you use what?
Log.
There we go. So then you say log of 2t over 3 equals to 100. Log of 100, sorry. And then what else? So we know that this is equals to t over 3 log of 100 of 2. Are we all together?
Yes, ma'am.
But we know that 100 can be written log. I'm just simplifying so that you see how I'll also put it in the exam. Log of 10. Do you agree there?
Yes.
Yes.
So then this will be 2 log of 10 over log of 2 over log of 2. Then multiply by 3 this side. So this is t is equals to, I think, over 3. Okay, let me not make a mistake. 2 log of 10 over log of 2. log of 2. So I think if we take this here, so this will be t is equals to 6 log of
Yes.
10 over log of 2.
Yes.
And that's your time.
Yes.
Do you see that, guys?
Yes.
So let's go and
Yes, ma'am.
see if. So let's see. There we go. 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 Okay, where did we miss it? Please help. Where did we miss it?
No, the log of 10, and the common log is 10. So 10 of 10.
How, Nkosi yami? Yes, thank you very much. Did you hear that?
Yes. So log of 10
Yes.
is 1.
Yes.
Alright.
Guys, you guys are cocos. You guys are cocos, eh? So log of 10 is 1, 6 over log of 2. I'm telling you, the student has become the master, better than the master. Well done. So then that's 6 log of 2, which is this one over here. Now imagine if I had something that looks like that in the exam. Someone was going to get it wrong. But do you see how we simplify it? Guys, you gave me goosebumps. What do you call them?
Butterflies.
Yes, but they call them goosebumps.
City butterfly. City butterfly.
Getting goosebumps where my skin is even having chicken skin. I'm proud of you guys.
Yeah, it's goosebumps.
Yes,
It's goosebumps.
yes, you gave me goosebumps there. Thank you very much. So that's how you see how we are solving without calculators.
Mm-hmm.
Thank you. So if you yes, if you continue like this, guys, then you will not only your thinking should not only apply for this module but every module. Exponential growth. So now we're no longer looking at doubling. We're looking at
Sorry,
relative
ma'am.
growth rates.
Sorry, ma'am.
Yes.
Sorry, ma'am. Before you continue, can he also GPS as where is he getting that basic knowledge for getting that one?
Where are you getting that basic knowledge for getting that one?
So that we're not gonna be confused when we get to the exam as well.
Where did you get the basic knowledge of getting one? Eh? Guys,
Where
the
you
person
see
who the person who said log 10 is 1. Where did you get that basic knowledge? And then he disappears. Remember, we have been saying, guys, because of the one-to-one property and the logarithmic laws, we know that the common log, it's log of x, its base is what? Is log 10 x, right? So if you put 10 here, so then log of 10 to the power of 1. 10 is the same. Therefore, we know according to the log law properties or the inverse property, this will disappear and will only remain with that one. That's where he gets the 1. It's something that we've been talking about all along.
Okay, ma'am. Thank
Yes.
you.
And guys, one thing I need to just tell you, maths is continuous, right? Now, you can't come to this class if you didn't go through last week's recording. If you were not in class, make sure you go through last week's recording with your NAT data then, or go to, almost said a place. They'll go to these places where there's free Wi-Fi, mall, whatever, and whatsoever, and download those videos and go and watch them. Because then it will help you to continue to these new sections. Now, exponential growth. So we have relative growth. Remember, initially we have doubling. So you need to know when to use this formula here. This one here. This is when you have a doubling time. That's when you use this formula over here. Right? And know it by heart because there's no formula sheet, by the way. Now, let's go to, Let's go to exponential growth, relative growth rate. We have used an exponential function with base 2 to model population growth in terms of doubling time, right? But in most cases, guys, you can't say every 2 years the population is growing. Like, for example, you can't say the population in Africa is growing, is doubling every 2 years, right? Sometimes after 2 years it can triple, or sometimes after 3 years it can be less on whatsoever. So which then type of model are we using? Now, go back. We have used an exponential function with base 2 to model population growth in terms of doubling time. Now they're saying that we can also model the same population. Now, if they're saying that the population is growing exponential with a base of 3, meaning that it's tripling. So here, if it was if the population was tripling, it means this formula will be what? Will be 3 here instead. If they say tripling time, if they put triple here, then it means this part here will be 3. If the population was 4 times in whatever time, then that will be 4. That's what they're saying. So let's move on. Now they're saying that, in fact, we can find an exponential model with any base. If we use the base E, we get a population model in terms of a relative growth, meaning that the population is growing at the rate of, therefore, we're going to use base E instead of using base 2 or 3. The rate of population growth expressed as a proportion of the population at any time. So now they say, in this case, R is the instantaneous growth rate. In calculus, the concept of instantaneous rate is given a precise meaning. We'll know that when we're doing calculus. For instance, if R is equals to 0.02, then at any time, the growth rate is 2% of the population at that time. Does that make sense, guys? So they don't say that the population doubles, but then they might say that the population grows at the rate of 2%. Same applies to our inflation. It grows at the rate of, I don't know whether 5% or whatsoever. Right? So now the exponential growth, relative growth rates. A population that experiences exponential growth increases according to this one here. Do you see that we no longer have an E2 here, we have an E here. Now they say NT is the population after time T initially, N0 is the initial size of the population, R is the relative rate growth expressed as a proportion of the population, and T is the time. Now they say, notice that the formula for the population growth is the same as the continuous compound interest formula. Did you notice that, guys? Am I
Yes,
talking too
ma'am.
much? You see, it's the same. They're saying that, notice that the population, I almost went back to the formula. I notice it's not in the slides. Notice that the formula for the population growth is the same as the continuous compound interest. In fact, the same principle is at work in both cases. The growth of a population or an investment per time period is proportional to the size of the population. Meaning, do you remember what proportionality means, guys?
Yes.
Yes.
What does
Yes.
mean? What does proportionality means?
Equal.
Equal.
The same.
Equally.
The
The same.
same.
When I say this is proportional to that, not similarity, but proportionality.
Ma'am, it means that it can enter like two times or a certain rate, if I can say so.
Proportionality shows the relationship between two what's this, 2 or 3 variables and whatsoever. For example, if I say this is proportional to this. Remember in physics, you had directly proportional and inversely proportional. Directly proportional, if I remember properly, says when one increases, the other increases as well. When one decreases, the other decreases, right? And then we had inversely proportional, meaning that when one increases, the other decreases. And when one decreases, the other increases. Do you see that? That's where you're looking at proportionality. Are we all together? Hello?
Yes.
Yes. So now they're saying the growth of population per time period is proportional to the size of the population. That is, a population of 100,000 will increase more in 1 year than a population of 1,000. So in exactly the same way as if you put 100, what is this, man? $1 million will increase more compared to putting someone who puts in $1,000. So they say in the next example, we assume that the population grows exponentially. So if we assume that population grows exponentially, which formula are we using? And then we have this example over here, guys. This is an example that we need to look at. Okay, let's not look at the sketching part. Let's just look at the top part. We know this is an exponential function. We know how to sketch exponential functions. So let's just look at what we are covering today. So they say initially a bacterium count in a culture is 500. A bacteria later makes a sample count of bacteria. A biologist later makes a sample count of bacteria in the culture and finds a relative rate growth of 40% per hour. Meaning that, okay, let me not say meaning that. Which formula are we using? Let's start there. I have NO2T over A, and I have NT, which is equals to NOERT. Which one are we using?
The second one.
Why?
Because it's not doubling, it has a relative growth.
Thank you, because it has a relative growth. Now, going back to the formula, let's go check. Just look at the formula just for a few minutes. R is our relative growth. T is our time, and N of T is initial. So let's go and solve the question. So meaning that they say find a function that models the number of bacteria after time T. So what is the function? It will be N of T equals to N0 ERT. What is initially? We initially had 500. Yeah, guys, my brains. We initially had 500. Then we had E. What is our R?
Makuru,
R is going to be 40% divided by.
Makuru.
It's going to be
100.
40%, but then we're going to convert it and get
To what?
to a number, which is going to be
0.4.
divide by 100, which is going to be 0.4.
Well done. Do you see that? Now they say, what is the estimate count after 10 hours? What do we do?
Substitute T
Substitute
with
10
10
to the
hours.
T.
Can we simplify this? It will be e to the power of? E to the power of what, guys?
40,
40.
I think.
Ah,
It's going to be e to the power of 4.
4.
Oh.
Oh, 4.
yeah. C. Let's go
You
to C.
you see, yo, ma'am.
We're not using calculators, guys. Let's go to C. Let's go to C. And in your assignment.
They gave us
Yes.
NT, ma'am.
Okay,
And
they gave us
they want
Wait,
T.
guys.
NT.
Wait, guys. What happened to that 4 to the exponent 10. Is it exponent 10 or is times 10? What is going on there?
We multiplied 10 by 0.4.
Okay, I'm still.
Remember, they said this bacteria increases by 40% per hour. So the 40% we converted it to rate, which is 0.4.
Oh, okay.
40 divided by 100.
Oh, then our answer is actually 4. Okay. No.
Yes.
I didn't see the 0.4. I thought it's 4 times 10. Sorry.
Now there's something, let me not tell you now, because I'll tell you an answer to something. So then this is what? 80,000 equals to 500 e to the power 0.40 divided by 5. I think by now we know what we're doing. Tell me here. What's that?
I don't know.
Oh,
We cancel the zeros first.
But we cancel the zeros first. Let's see.
And then it's 800 over 5.
It's going to, when you use long division, it's going to be 160.
How did you find it?
Use long division. Hallelujah.
What's 80 divided by 5?
Okay,
Let's start
okay.
there. Then add 0.
Maybe let's say
10,
5,
15,
5, 5, 10, 15, 20, 25, 30, 35.
Yes.
55,
If we can find 80 divided by 5.
55, 60. Oh, I ain't get it, guys, man. 60, 65, 70, 75.
I think it's 80.
I think it's 26 or something.
Isn't it 90 or something? Because
It's 80.
80 divided by 5.
5,
Yes.
10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. It's 16.
Then
Yes,
add
it's going to be
0. 160.
160
Via
or
long
I
division.
don't know.
Guys, how many fingers do you have?
160, ma'am. I think
10.
it's 160.
10.
160 or 16? Yo,
It's
I
160.
yeah, I think it's 160, ma'am.
Don't think it is 160.
Yo, guys,
No, because when you say ma'am, I think ma'am is going to be like, what's the other answer? It's 160.
160.
guys, yo, this is
Definitely
the most
160.
challenging.
How about we do it like this?
Do it even via long division. Long division method from
Or
primary
we can say,
works.
or we can say,
Can someone
um,
come with a simple way of these numbers, guys? Because
can
some of
I
us they're
try?
making us. You can say what?
I think we can do it like this. 100 has got 10 5. And then if it's 800, then it's going to be 80. Because that means 800 divided by 5 is going to be 80.
You know. I think the easiest way here is to leave the 0 on the side and deal with 80 divided by 5, just like I just did now, and I got 16, and then you're gonna add that 0 again, and it's gonna be 160. I think it's easier that way.
Guys, yo, I'm seeing flames here.
You see, ma'am. Let us use the calculator.
80 times 10.
Okay, can I
80
ask
times 10.
Anastasia? Can I ask something?
Yes.
What is 100 divided by 5?
10.
No, 100 divided by 5 is 20. It's not 5, right?
25. What?
What did you say?
It's
No,
20.
100 divided by 5 is 20, isn't it so?
Yes.
Yes.
Yeah, so in 800, how many 20s do we have?
Then
Isn't it
100
160?
divided by 5 is 20.
Isn't it 160?
48. 100, 120.
If you give 25 and then it comes into 8, isn't it 160?
It's gonna, yeah, it's like that. I think that one is the easiest one. Yeah.
Okay, cool.
Okay, 80 times 10. This is mine. 80 times 10.
800.
800.
Divide by 5.
That's where you
Then you're
go.
gonna get 160.
It's 160.
Fancy gift. Cause the
No,
Yeah,
eight.
you want
180.
Sigist,
You're going
yes.
to say the 10 divided by 80 divided by 5 and then the 10 divided by 5. I don't know.
Can't say that. That's not maths. You can choose which one you want to divide. You can divide this
the
one
10.
or divide this one with the 5. Do you see that?
Mm.
Yes. You choose. Me, I like life easy. I know that 80 divided by 5, I only have 10 fingers. I can't go 5, 10, 15, 20. I'll leave 80. And I'll say, okay, let me divide this. Because this is the same as 80 divided by 1 times 10 divided by 5. Do you see that?
Mm.
So 0.40. So then this I know it's 2. 2 times 80 is 160.
But ma'am, it's still making it hard most. If you
If they ever get started, they might just kick sideways. They're always
we wanna find the simplest way to find this answer.
You're making it. Ooh, guys, you're saying I'm making it hard. How? Because here, look at this. Look at this. You can also say 80 times 2 times 5. Do you see that? Divide by 5.
Yo.
Guys, someone is muted. You know why I'm doing it like that? Because I know that 2 times 5 is 10. 10 times 8 is 800. Do you see that? You just break it down. That's how I will do it.
Cancel and 8 times 2 is 160.
Yes, then the 5 can't, not form 1. Go back to your grade 12 teacher like mine, they'll say it cancels. Then you're left with this, which is 160.
Mina, I use long division because
Anyhow, if a cow comes,
use the long one.
yes, if a
Now,
cow comes
I'm
and it
becoming
has,
more confused. But at least now we have the idea of how to calculate without in calculus.
yes, because with calculus you don't use a calculator as well.
Yo.
Do you see that? That's why I'm saying that as long as you get to a point where you know that, okay, here I am going to learn not to use a calculator. Do you see that? So that's what matters. I know by now you know we have to use ln t is equals to 160, and then this is 0.04 is 40, sorry, equals to 160 ln. So then this is what, guys, I'm so tired. That's kisto 160 over 0.4. Is that right? For t. Guys, is it right, or should we go and check the answers now?
It's right, man.
I think it's right.
it's
Let's
right.
go check the answers. The first one we were right, yes, e to the power 4. The second one we were right. Oh.
Yeah.
Now we can go and draw. You know how to draw an exponential function, so here they drew it. Now let's go to radioactive decay. That is part of your assignment 3. We are so basically this class is solving the last question. Is it the last question?
Yes.
Yes, we are solving the last question in this class. Do you remember what was it talking about?
Bacteria.
It means we have solved it. Have we solved it already?
Yes.
Thank you. So we can leave the class, ne? And this one will be in the exam. So it doesn't matter. Okay, so let's look at radiative decay then. So the radioactive substance decay by spontaneously emitting radiation. So the rate of decay is proportional to the mass of the substance. So the rate at which it decay is proportional, whether it's directly proportional or inversely proportional, we'll see that. But if you look at in your mind, if something had a mass of, let's say insimbi, a metal, right, had a mass of 50 gram. Do you think in 5 years it will have a mass of 50 gram?
No.
Will the mass increase or decrease?
Decrease.
Why?
It corrodes. I think that's the
Yes.
English word.
Okay. Oh, that's a high English. Simplify it into an African language, not in our queens, into the
Yahusa.
British queen. Yahusa, yahusa.
Yes.
So when it
Rust.
russes, yes, when it russes and rust, I almost said our queen, the British queen. Yeah. When it russes and it russes, it loses what? It loses its mass. So that's what they are saying, the proportional. So they are saying that the radioactive substance decay spontaneously emitting radiation. The rate of decay is proportional to what? To its substance. So they say that this is analogous, I think, same to population growth. I know that analogous. Hey guys, I know that word means similar or same to population. So they say this is similar to population growth, except that the mass decreases. Do you see that? Now the mass doesn't increase, as we say, yavusa. Physicists, whoever are going to be physicists in this class, express the rate of decay in terms of half-life. So they look at half-life. So they'll say the time it takes for a substance for a sample of a substance to decay to half its original mass. Are we all together? Yes or no?
Yes, word.
Yes. Okay. So now they're saying that, okay, for example, the half-life of a radium-226, please reduce. We don't know what a radium-226, we know it's one of those materials. I don't know it's a copper or what we don't know it, but it's a radium-226. In 1,600 years. So a 100-gram sample, meaning that if you take a 100-gram sample, right, of that radium, it will decay to 50 gram, meaning that it will be half of its original in 1,600 years. Does it make sense on how they are reading it? Guys?
No.
Hello?
No.
They are saying that if you have a copper, for example, I don't know how, they say if you have a copper in 1,500 years, if your copper was 1 kg, in 1,500 years, it will be 50, what's half of 1 kg? 500 grams. That's what they're
0.5.
saying. Yes, 500 grams, so half of that. So they are saying that this radium-266, I don't know what it is, in 1,600 years, it will be half the original weight. That's what they are saying. That's what we're talking about here. Are we all together, yes or no, guys? Hello? Are we still here?
Yes, ma'am. Yes, ma'am.
I
So
thought,
so they are saying it decreases by half or to half every 1,600 years.
yes. So that's why they say that's how the physicists express the rate of change with radioactive substances, because they work with radioactive substances. So they measure it in half years, half-life, I mean. So they'll say in the next, how many years will the mass be half of the original? That's what they are doing. Now they say that in general, for a radioactive substance with mass MO and half-life, meaning that I know now I have 5 kg of copper, right? In 15 years or 25 years, I'll have what? 2.5 kg of copper. Which model am I going to use to model life? Model that problem. It's this one here. That one. So they say in general, for a radioactive substance with mass 0 and a half-life of H, the amount remaining after T is modeled by this formula here, where H and T are measured in the same time. Guys, H and T are measured in the same time. So if one is in years, one is in months, you need to do some conversion. Are we all together?
Yes, ma'am.
Yes,
Thank
ma'am.
you. Now they say to express this model in terms of MT is equals to M0 equals to E to the power of RT, meaning that where we have a rate of change, the reason, no, not the rate of change, the relative rate of decay. The reason why we have a relative rate of decay, same applies to the problem of bacteria. Not every time bacterians double. Remember what we said, right?
Yes.
So not every time we'll know it's okay, fine, after half years and whatsoever. So then we want to move away from this half what to come and have and remain here, where we have a relative decay. And say, instead of saying after 2 years it will decay, we just know it's okay, fine. If we have 5 kg of 5 kg of copper, this copper weighs 5 kg. In 2 years' time, what would it weigh? Instead of saying, let's wait for 50 years for it to weigh half of the original amount. So meaning that we use the relative decay. So we want to move from here to here. So how do we move from there to there? So then they say, okay, fine. We need to find the relative decay, which is R, meaning we need to find R. Since H is a half-life, we can then use this formula here. But we know that if we put H here, inside where we see T, by according to this formula, we know that this will be equals to half of its original. That's why we end up here in the formula. You don't have to know how to derive that, but at the end of the day, if you simplify, your R will be this, where we have the relative rate decay. So then it means our formula becomes like this, where we say a radioactive decay model. If initially we had copper, a radioactive substance, I don't know what a radioactive substance, physicists will tell us. Next year when you isn't that you'll be doing BSc in physics, you'll come back when you understand radioactive to come and explain to us
We
as a
know what it
physicist.
means.
Yes, do you see that? So those who know, they'll tell us what are radioactive substances. So they say if initially a radioactive substance has a mass, this meaning 5 kilogram, for example, with a half-life H, then the remaining after time T will be this one. Do you see that? Where R is equals to ln 2 over H, which is a relative decay. Here's the question. I'm glad now that we have finished assignment 2. Assignment 3. So we go to assignment 4 and then go to assignment 5. Okay. I see people don't want to say anything now because they've solved their problem, their whole assignment. So they say a polonium 200/200 what PO, you know what that is, has a half-life of 140. So what is 140 in the formula? Guys, what is 140?
T.
It's what?
T.
T. Half-life. They say with a half-life of H. So 140 is what is H. Do you see that? So let's go back. So they say it has a half-life of 140. So meaning that our H is equals to 140 what? Days. Next. Now they say suppose a sample of this substance has a mass of 300 milligrams. What is 300 in this formula?
It's MO.
Well done. It's MO. Let me cut this formula and put it because someone is guys, I can hear your aunties. Please mute. Thank you. Okay, where can we put it here? Let's see if it'll fit here. Yay! Okay. This is can you see the formula so that we see it? Alrighty. So we have H is equals to 140. Right? Okay, let me see if I move it this side. Yeah, it can't move. And then they say that MO is equals to 300. Now, first question says that find a function MT equals to MO 2 to the power of negative T over H that models the mass remaining after time T. So what do they want us to do there for A? What do you think they want us to do for A?
Find the formula.
So meaning they just want us to substitute. So meaning M of T is equals to 300 2 to the power of minus T over 140. That's what they want us to do, I think. And then B. Please help with B.
For B, I think we have to find R.
All righty. So what is R?
So your R is going to be ln 2 over H, which is given there. Then
Well done.
yes.
Then
Then you're going to use the formula that the MT is equals to ME raised to the power negative RT. And then
okay,
you're going to substitute M, which is 300. E. Then you substitute your R, which is found there. Then
Thank you.
40 T.
Tango. And then they say, find the mass remaining after 1 year. What do we do here?
Substitute 1 at T.
I'm going to drink water. Discuss number C.
Wait, guys. When it comes to these ones, we're not supposed to convert the years. This year, I mean years. We're not supposed to convert them like we were converting them when we're doing other calculations.
Yeah, because you see, for B, they say that T is days, meaning that we can't use 1 because 1 is
Exactly.
auxiliary. We're supposed to
We're
use
supposed to be
365.
0,01.
Now we're supposed to use 365 because
We're
it's the
supposed-
number. It's the 365 is the number of days in a year, and we're given that T is measured by days, not by years.
Oh, it's measured by days.
Yes. So it's going to be our T there is going to be 365 because it says days. I can remember T and H use the same measuring unit.
Mm-hmm.
Yeah.
So now when we convert the 1 year, we
The
also
1 year. I get the 1 year is just we converting the 1 year. What do you mean? Sorry to interject you.
No, I'm saying 1 year is 360 days, well, and then we're gonna convert the 365 days, ne? Or
Can
what
I
are we gonna,
interject?
or we
Yeah,
just
you
gonna
can.
write 365
I
exactly?
think it's
You just write
easier
365.
to just use the one, and then after finding your final answer, that's when you're gonna convert it to days. Because now you'll be working, trying to figure out what is a 360, you subtracting the, I don't know how you're gonna work that out, but I think if you just put the 1 year and then at the end of the answer, you'll work out what the 360 days are and stuff. I don't know, just my 2 cents.
Aren't we supposed to show the proper method immediately after when you substitute? Because
But how will you
even even
simplify?
even 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 when we're doing those compound interest, like you have to convert the years immediately, and then when you substitute, you're gonna put them while they are already substituted.
Yeah,
I
we
don't know
supposed
how you're going to do it without the use of a calculator.
because remember, mem it does not want the final answer. So if we just substitute and leave it like that,
Oh,
it's going to be fine. Because remember, it's also like a mark. If you write one, it means that you won't get your mark because you're already given that T is
yeah, yeah,
365
you're
days.
giving a year,
And
not
in the
not
past,
days. Yeah, because if
yes,
we
and
if we're
in the
putting
past
one, it's more
questions,
like we're putting a year instead of putting
yes.
the days that we're supposed to put in the equation as we
But
substitute.
remember the question says half yearly. Is the half life what? So if you
Half-life,
say
what? Hungary is recalculating half-life, what?
mm-hmm,
Yes, which is R. The R is going to be the half-life what, which is R. R is already substituted. So what you're gonna do is to just substitute the T and leave it like that because you cannot further solve without a calculator.
so what is your T?
Your T is 365. I stand on this one.
Unless we're supposed to make it as a half, I don't know. But I think 365 is actually the one that we're supposed to substitute.
Yeah, you
Yeah,
are
Bona
right.
even meant circling, saying where H and T are measured in the same time units, minutes, hours, days, years, and so on. So we're given that H is measured already in
In
yeah,
days.
in days.
In days, so it's 365, obviously.
So it's 365.
Well done.
Oh,
You guys are listening. I thought I was just alone. So because T is measured in years and what's this? Because now the half-life here is measured in days, meaning that your T also has to be in days. So therefore, how many days are in a year? There are 365. So 1 year is equals to 365. So therefore, there will be 365 equals to, look guys, my brain, 365 is equal. Are they 365 eh? Hey, or is it me telling you?
You don't trust yourself.
then there are 365 days and a quarter in a year, but because
Isn't that? I'm tired, guys. So my brain is telling me 355.
no,
It's
no, ma'am.
So
365.
well done. The reason why I want you to discuss, and guys, I've noticed that you haven't started those discussion classes. Maybe you will start them when you are doing the memo. The reason why you end up discussing like this is because you are showing each other ideas and coming together to understand. When you're studying alone, it's not easy. I know last year's group, they'll do night data. Like you see that the one doing at night, they'll meet at a certain time at night, maybe 12 or what. I will call them, they'll explain how they met, and they'll be discussing such questions, basically, especially when it comes to doing the memo. That's where they were discussing. So you can isn't that you are seeing your people who to discuss with? I can't see names. You are seeing names. So isn't that you are seeing who's discussing? So then that group will then meet and discuss.
Hi guys, you can hit me up on my email.
Yes, hashtag will send the email at the end. How long okay, let's look at how long will it take for a sample to decay to a mass of 200 grams. So what do we do there? Number D. Guys, what do we
So
do?
what we do is that our MT is going to be equals to 200.
Alrighty. So meaning that this will be equals to 300 E minus ln of 2 over 140 T.
Then
Okay,
you
then we do what?
divide both sides by 300.
Right? 100.
300.
Oh, I was like 800. Divide both sides by 800. I'm like, hey, la, la. So this becomes what? 200 divided by 300, guys?
Going to be 2 over 3.
2 over
0
3.
cancels 0, 0 cancels 0.
Ala, ala. Do you see now people know how to do this thing now?
Aye,
E
this one is
minus
different.
Man.
now, guys, you need to be baked. By the time you go to calculus next year, all of you need to be baked, fully baked. And engineering maths, all of you need to fully baked. Think. Because now we are doing now. Remember, they say one of the skills needed in this fourth industrial revolution is critical thinkers, not thinkers. So then what do we do now?
I think we're gonna use the lean.
Well done. Guys, Muswena, you guys are answering a question in the exam because it will be in modeling. Ln of E, ln of 2, 140T equals to ln of 2 over 3. Then what?
Bring down the ln.
Exponent. Okay,
Yes,
minus.
exponent.
We know that this just remains as 1 if we remain with this. So we can just leave it like that for now. Then what do we do?
Divide by the ln. 2 over 140 minus, so 40.
So then T is equals to what?
Ln 2 over 3 over ln 2 over 140.
Let's simplify that.
Minus 140 ln 2 over 3
So we know
divided by
that
ln
this
2.
we can write as ln of 2 over 3 divided by negative ln of 2 over 140. And you know when we divide, you can multiply. It changes to multiply. So 2 over 3 times 140 over minus ln of 2. So then this is equals to 140 ln of 2 over 3 over minus ln of 2. Are we all together? That's our T.
We can't times those ones. We're just gonna leave it like that.
Yeah, we just leave it like that. There's nothing we can do.
Okay.
You don't want to simplify on top and say 140 open bracket ln of 2 minus ln. Just leave it like that.
Okay.
Let's see. Okay. Is there any?
You don't wanna lose marks, ma'am.
Oh, you don't. You don't. Draw a graph. You know how to draw a graph, exponential graph. Hey, guys. Hey. I'm telling you. 365. Ah. Ah. Didn't want to simplify this for us. So we are fine. We didn't, because they didn't have that part because they simplify with the calculator here. So we don't want to do that. So do you see how we are leaving it in terms of ln, guys?
Yes.
Now there's Newton's cooling law. What do you think cooling means?
Decrease
What
of
did decrease what?
temperature.
Decrease of temperature.
Decrease of temperature.
Thank you. So Newton's law of cooling states that the rate at which an object cools is proportional to the temperature difference between the object and its surrounding, provided that the temperature difference is it's not too large. Now, guys, okay, before we say that, let me just continue. By using calculus, the following model can be deduced from this law. Newton's law of cooling, it says if D0 is the initial temperature difference, what does it mean? Between an object and its surrounding temperature. What does that mean, guys? Okay, let me not ask you now. If D0 is the initial temperature difference between an object and its surrounding, and if its surrounding temperature if surrounding has a temperature of what? Has a temperature of Ts, then the temperature of the object at T is modeled by the function T is equals to Ts plus D0 e to the power of negative Kt, where K is a positive constant that depends on the type of object. So, object. How? Straight into an example. Okay? I need my information. Okay, I need my information, which is this one over here. At the rate we are moving, it means we'll finish the assignment. What's this? The syllabus before the exam, which is good. Unless you want me to move slow. So if we don't finish the chapters before the syllabus, it means that you will finish the remaining chapters by yourself. Which one is which? I'm just putting that in your mind. Okay, you will draw the last part, guys. I'm giving you an example to illustrate the drawing of the temperature. I'm just copying here so that make things live easier for us. Yes, yes, yes. We all can see here, ne?
Ma'am, you didn't capture the question.
I did.
You did?
The question, this one.
I think D is left out.
Yeah, this is homework for you to guys go and draw. Isn't that we did drawing of exponentials previously? So now what I know, you know, then we do what you don't know.
Sure. Okay.
Okay, ask case. They say a cup of coffee. I don't drink coffee. I'm very hyperactive, guys. So if I drink coffee, I'll run around. A cup of coffee has a temperature of 200 Fahrenheit. Is it Fahrenheit or what? Yes, that one. And it's placed in a room that has a temperature of 70 degrees Fahrenheit. After 10 minutes, the temperature of the coffee is 150 Fahrenheit. Hey, guys, I don't remember. Is it Fahrenheit or what? Let's go to degrees Celsius for now. Or look, Fahrenheit. Find a function that models the temperature of the coffee at time t. Let's do that. Let's do that, guys.
So we're going to write down the formula.
That initial.
Let's start the formula. Yeah. E minus KT. That's the formula. We wrote down the formula.
And you need to find the difference first.
What is the difference? Is it TS?
Of an object and what?
So which one is the difference? Is it TS or D0?
It's D0.
It's D0.
D0 is the difference between?
Sure.
What's the difference,
the initial
guys?
temperature and the one It has decreased too.
Difference is the answer that you get for subtracting. So what are we subtracting?
I
The
think
initial temperature.
the initial temperature,
Initial.
which is 200, I think. 200.
Yes, the initial temperature of the object in this time. Our object is coffee, isn't it? So that's 200.
And our surrounding is
70 degrees
70
Fahrenheit.
degrees.
Yeah, Fahrenheit or Fahrenheit.
Fahrenheit to done.
Yes. So this is what? What do we get?
130.
I don't know.
130. You can't say you don't know when you are able to divide 800 by 5. Yeah, 130
It comes and
degrees
goes.
It comes and goes. Sleep. When you're going to write maths, when you write exams, sleep, guys. Don't study night before. Sleep so that you can think. Now that we find with D, so it means that because they want it in T, ne? So then A is what? What is TS, guys? What is our TS?
Then it's the
70.
70. Did anyone not understand why is it 70? It's because TS is the surrounding temperature.
surrounding temperature.
Is this one over here?
Mm.
Yeah, so then we go and substitute. T is equals to TS, which is 70 plus DO, which is 130, E minus K of T. Are we all okay?
Yes.
Yes.
Now B says find the temperature of the coffee after tea. Wait, something is wrong here.
You're not done.
We're not
Yes.
done. We left the 150. What? After 10 minutes, what is going on?
Thank you. So that 150 will help us to find what?
What happens to find? Is it K? Is there
Well
K?
done. Well
K.
done. So how do we find it then?
Then you got T. You're going to substitute 150.
Thank you. 150, then what?
Is equals to 70 plus 130. Raised to negative 10. K.
Guys, yeah. This question is going to get marks in the exam. This section, this section is there in the exam, guys. I'm just telling you, this whole section, one of the question, whether it's radioactive, whether it's half cooling neutron, what, it's going to get marks.
And then it's going to be 150 minus 70, which is 80.
And
Is equals to 130 E minus divide both sides by 130.
I want us to write it like this because the other part, and then people, me, I can use a calculator. Alala. I want your brains to be cooked and baked by the time you leave here.
8 over 13.
What?
Introduce length to both sides. Huh?
Then?
Like so easy.
Negative 10. Okay.
Then
Divide
K?
by negative 10. K is equals to
Divided by negative 10K.
Then?
We can change and multiply into 8 divided by 13 times 10 over 1.
You want to change what? Wait. What do you want to change?
Ma'am, didn't you say you can also multiply for you to get the answer, or it doesn't apply here?
Wow, that's where I need to know because you are going very well, and then
It doesn't apply here because it's not the same.
Oh,
Oh,
and
ma'am,
then
she's saying what she's
I'm
saying.
saying
I'm going
you.
to say that when we divide and we can multiply if it's like two fractions.
Oh no, here it's fine because 8/9 is inside the lane.
okay.
Yeah. Hey, I saw you were going very well here, and then you disappeared. What do the petty people say? Utsamailele Saule King. Saule weteng.
Ujere ke sauwe.
Ucheri ki Saule. You were going very well, and Saule came and took you. So no, you don't do that because Lynn covers everything.
Okay.
Yes. Well done. Alrighty. So now I'm lost. I'm lost myself. Okay. So this is 70 plus 130. Okay. 70 plus 130. I need to remember that, guys. This is 70 plus 130 minus. So the minus and minus cancel, isn't it? So then this is, okay, let's just say minus, because there was a minus here, ln of 8 of 13 over 10 times t. So this is equals to 70 plus 130 e cancel. So ln of 8 over 13 over 10 t. Then we are done with the first one. Are we happy?
Yes, ma'am.
Danko. Okay, let's see. Yeah, you see this thing or not? Number 12. So what does B want us to do?
Wants us to substitute T as T, which is the temperature. The small t is 15.
It's 15.
No, we finding the temperature, so substitute the small t is 15.
So they want us to find the coffee after 15 minutes. So meaning that, okay, I need these two guys. How do you copy at the same time? Okay, we'll just come back. So we'll put 15 there. So they want us to put 15 here. Do you see that? So they want us at, is it 15 minutes? What are they saying? What's the question? Let me go to the slides. The question says, find the temperature after 15 minutes. So meaning that we substitute 15 into what we found.
Yes.
So let's do that. So then we put 15 equals to 70 plus 130 e ln of 8 over 13 divided by 10. 10 times what? 15. And we can have this, we can simplify this, and 130 e, how many? It's 3 over 2. Am I right? So it's 3 ln of 8 over 13 over 2. Because there's a 10 there and there's a 15 there. Are we all together, guys? So far, so good.
Mm.
That was fun.
Can you repeat that, ma'am?
Isn't
Where
that
did you
here
get the 3 over 2,
Can
ma'am?
ma'am, can you calculate that on the side, like and make it?
Look, isn't that here? It's ln of 8 over 13 times 10 times t, and we put t here. Do you see that? And now we
15
know that
divided
the
by 10.
15 divided by 10 is 3 over 2. How many fives are in here? There are 2. There are 3. How many fives are in here? There are 2. That's where I got the 3 over 2.
Okay.
Yes.
And
And
then we take the 3 and where did it go? Where did the 3 go now?
it went in front here.
Oh,
Multiplication is
oh.
commutative.
I guess my
Oh,
eyes were not
multiply.
looking. My eyes are the one.
Multiplication is quantitative. It means that how tomilega A wa multiply B, and then B is the same as multiplying by A. It's commutative, something like that. Yeah.
That one.
Mama,
Yes.
Mama, I think we were writing fast. I didn't see the 3. Where did it go? That's why I was confused. I think you were or 5.
Askis. No, I understand. Askis, I will have to write slow as well because now our petrol is finishing. But don't worry, we'll finish soon. I know our brains are not here anymore. Okay, so then now they say how long will the coffee have been cooled to 100 Fahrenheit? What are they looking there for?
They want the time.
Angle. Guys, it means this section JI. I will not even cry when I see your paper, when I see your questions. When you're writing, I can see you writing there.
Ma'am, you know
And I
what's
look
gonna
at the
make you
marks.
cry?
Don't give me what's going to make me cry. So we put 100 here. At T is equals to 70 plus 130 E.
Mem is marking our name. Okay.
Over what?
You're marking our names.
How?
Yeah, this one and this one were answering me during this section.
No, I'm not.
No,
I'm
ma'am is
not.
not like that.
I go and check the statistics. Isn't that when you write question 1, let's say everyone finished question 1, the statistics will show me that in question 1, how many people got question 1. Like I'm looking at that, the statistics. Yes.
Okay, ma'am, let's continue.
Yeah, bros. So then we take this will be 100 minus 70 equals to 130. I hope we don't make errors because I see here I'm so tired as well and hungry at the same time. Yeah. So this is 30 equals to 130 ln of 8 over 13. Now you know how we're going to solve our questions in the exam, isn't it?
3 over 13.
You see? How? Hey, I'm telling you. The speed. Hey, guys, you see what I'm seeing? 8 over 13 over 10t. Meaning that we introduce ln both sides. So then this is equals to, we remain with ln of 8 over 13 t over 10 is equals to 3 over 13. Then we times by 10. So this is the same as what? So this will be what? I think this will be, help guys. Oh.
Ln 3 over 30.
So it will what? 30 over 13 ln of 8 over 13. Something like that.
Yeah,
If we do it,
Yes, ma'am.
if you do
what
it,
matters, even if the answer right now is wrong, what matters is you guys were able to do all the questions and like you know the step, you understand everything. This is what matters to me. Very important. So
yes, ma'am.
got it. And this is what we got. And someone was like, no, K is missing, ma'am. And then we went and found our K. And they even say 8 over 13. Ha! Without a calculator. Hey, guys. But I'm creating monsters here. 8 over 13, it was Lynn. I'm creating monsters. And they're like, yeah, K is equals to negative 1 over. Hey, guys. So here you see, we will not end here. We'll not, because we're not using calculators, but this is where we'll end. And then we'll substitute it like that. From here, they are substituting the approximation. We are substituting the exact solution. Do you see that?
Yes, ma'am.
I'm glad that you knew what we are doing next. And like, yeah, 13 over, guys. Hey, I'm laughing. I'm laughing for people who say they don't know how to use a calculator. Now, this is one of the graphs. Do you see that at some point this will be an asymptote? 70 will be an asymptote. Therefore, it will approach 70. At some point, it will be not really at equilibrium, but it cannot be below 70, isn't it? Guys, you can't put coffee in one room. Yes, it will cool, but you can't tell me with that temperature it will freeze at some point.
No,
Do
it
you
will
see that?
never.
Yes. So meaning that there
Yes.
should be an asymptote. So in this case, the asymptote is this one here. Oh. Hey, yeah, I'm happy. And the guys are gone. Guys, what's going on? Man, I don't hear the voices.
It's a sign.
Is
We are
it
here.
time? Are you
We were
guys
just
tired? Yes. Is there a question? As long as in corner, my fit. That's my favorite. Or maybe you're not the afternoon people. All right, see, is there a question based on this work that you guys have? If there's no question, it means assignment 3 will be covered and we'll understand assignment 3, which will help us to understand our final work.
We are submitting today, ma'am.
Danko.
Not today, ma'am. Next week.
Danko. As long as it's not on the day of the due date, guys. Discipline. It is spring. Huh?
Mm-hmm.
Yes. As long as it's not on the day of the due date. Remember what you are learning.